Today we learned about special triangles. These are very special triangles, and they are triangles that have the degree measures of 45, 45, and 90. Let's begin by explaining what a special triangle is. Let's say we start with a square, this blue square here. We have side length x, and a square has all equal sides, so we know that these all would be x. Now let's say we cut a diagonal on this square and created this triangle here. The diagonal cut this angle into two 45-degree angles, and it cut this angle into two 45-degree angles. That is why this triangle over here has a 90-degree angle and then two 45-degree angles. Now because this was a square with side lengths x, the two sides of the triangle that come from the square are x and x. This here is a hypotenuse. Now, the special triangle rule tells us that this hypotenuse is always going to be x times the square root of 2 in a 45, 45, in a 45, 45, 90 special triangle. Where did they get that number from, though? Let's find out. So let's say we take this triangle here and we use Pythagorean theorem. So remember Pythagorean theorem from yesterday? Let's call this D, let's call this Y, okay? Just so we're using a different variable. So we have x here, y here, and x here. Pythagorean theorem yesterday told us that a squared plus b squared equals c squared in any right triangle. This is a right triangle because it has a 90-degree angle. So what is the first thing we always do with Pythagorean theorem? We find c. C is always going to be the hypotenuse, or the side across from the 90-degree angle. So in this case here, c is y squared. And the other two sides, a and b, are x. So we have x squared plus x squared equals y squared. Equals y squared. Now we want to solve for y because we want to find out what y is. We don't know what y is, so let's solve for this and find it out. In order to get rid of the exponent, we square root both sides and we get y equals the square root of x squared plus x squared. What's x squared plus x squared? 2x squared. What does the square root of 2x squared break up into? The square root of 2 and the square root of x squared. What's the square root of x squared? X. What's the square root of 2? We'll just leave it as the square root of 2. Now look at the diagram up here. This, x times the square root of 2, shown here, is now substituting the value of y from over here. And that's how we get this relationship for a special 45, 45, 90 triangle. So if you ever have a triangle that looks like this, 45 degrees, 45 degrees, 90 degrees, you can tell that the side measures will be x here, and x radical 2 on the hypotenuse. So this works both ways. If you see a triangle that looks like this, you know that you can use a special triangle rule. And if you have side lengths of, let's say, 2, 2, and 2 radical 2, you can know that these angles here will be 45, 45, and 90. Just like all the rules that we learned before, they work both ways. Okay, let's do an example. So, first we fill in all of the missing information that we know for sure. We know that this angle here is 45, this is 45, and this is 90. Then we let the angles guide us to what the side measures will be. So the side across from the 90-degree angle is always x square root of 2. The side across from the 45-degree angle is always x, and the side across from the 45-degree angle is always the other x. So now, do we have any information from the problem? Yes, we do. We know that x equals 3. So let's put that over here too. And we know that the x here is going to be 3. And the new answer will be y equals 3 times the square root of 2. This is y here. We found this to be 3 times the square root of 2. And x equals 3. Now let's test what we used yesterday to prove if this is correct or not. So let's say this triangle, I redraw it, right? Oh, that doesn't look so good. I redraw it over here, right? It's going to have the same dimensions as the one to the left. I have 3 here, 3 here, 3 square root of 2 here, right? So technically, I start with my Pythagorean theorem. I find C. C is always across from the right angle. C is 3 times the square root of 2 squared. This is A, this is B. We get 9 plus 9 equals 3 times the square root of 2 times 3 times the square root of 2 gives me 9 times 2 gives me 18. 18 equals 18. We got the answer right. Let's do another one. Okay, right here. It says find the distance from home plate to second base. So from home plate to second base, this here is home plate, this here is second base. Okay, this is the distance we're trying to find. If the bases are 90 feet apart. So the diagram tells us the bases are 90 feet apart. So let's separate this into a triangle that we can work with that isn't covered in pictures, okay? So I have my 90-degree angle here. I have 90 feet here. I have 90 feet here, and I have the distance that we're looking for here. This angle is 45 degrees. This angle is 45 degrees. If you ever see a triangle with a right angle and two 45-degree angles, we know that we can use special triangles. So let's match up our sides. The side across from the 45-degree angle is always x. The side across from the 45-degree angle is always x. And the side across from the right angle is always x times the square root of 2. So here the problem tells us that x equals 90. X equals 90. Therefore, d equals 90 times the square root of 2. Now, this is enough to answer the question, but let's double check our answer with Pythagorean theorem. So a squared plus b squared equals c squared. C is always across from the right angle, and c in this case, we found it to be 90 times the square root of 2. This here is a, this here is b. And we get 8100 plus 8100 equals 90 times 90 is 8100 times the square root of 2 times the square root of 2 times 2 gives me 16,200. 8100 plus 8100 is 16,200 equals 16,200. And we're all set. Let's try this one. Okay, we need to find x and y. So they tell us 90 degrees here, 45 degrees here. This one must be 45 degrees as well. We match up the sides across from the 45-degree angles and call them x. And the side across from the 90-degree angle becomes x times the square root of 2. So let us look at this problem. This is a little different than the other ones. In the other ones, we had x and we just substituted it over here. But this time, we are given the hypotenuse and we need to find x from the hypotenuse. So there's two different ways to solve these types of problems. When we are given the hypotenuse and not x, we need to set up an equation in order to solve for x. We divide both sides by the square root of 2, and we get x equals 20 over the square root of 2. Now we cannot leave a square root in the denominator, so we need to multiply the numerator and the denominator by the square root of 2. And we get 20 times the square root of 2 over 2 equals x. This reduces to 10 times the square root of 2 equals x. So x here is 10 times the square root of 2. X here is 10 times the square root of 2. And our hypotenuse here is 10 times the square root of 2 times the square root of 2, which reduces to 20. Therefore, y equals 10 times the square root of 2, and x as well equals 10 times the square root of 2. Let's try one last example. So this here is 45 degrees, therefore this one here is 45 degrees. We match up the sides across from the 45-degree angles and name them x, and the side across from the 90-degree angle becomes x times the square root of 2. Now, do we see any information here? Yes, we see that x equals 10. X equals 10, therefore the hypotenuse equals 10 times the square root of 2. Y equals 10 times the square root of 2, x equals 10.